Today we go into the next evidence, which is, we'll just call it design. And there's four aspects of it that I'll be dealing with today. The fine-tuning of the universe, what we call the Goldilocks principle, which is just the just rightness of the Earth and where it is. We'll also talk about nanomachines that have just come to light in recent decades, and the origin of information. The fine-tuning argument has to do with the fact that as scientists have become more and more acquainted with how things work, they've noticed that there are certain physical constants that run everything and that need to be within very precise ranges. In other words, they have to be almost exactly what they are for anything to work, and especially for complex life to exist. Now, these are not the laws of physics that we're talking about. These are constants, such as the strength of the force of gravity, or the expansion rate of the universe, or the total mass of the universe, or the relative masses of a proton and an electron. It's those kind of things that I'm talking about. They don't have to be, there's nothing that says, these have to be this way, these particular constants, by physical laws, but because they happen to be that, everything works. And so the question is, okay, why are things exactly the way they are in order for the universe to work? Okay, so the finely tuned universe, it's also called the teleological argument. Those of you that are taking notes about the fancy words that apply to these. Telos means a destination or a purpose. So this is the design, that it looks as though the universe were designed for a purpose.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
No large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
The strength of gravity is just one of at least 30 separate parameters that must be finely tuned to produce a life-sustaining universe. Another example is the cosmological constant.
The cosmological constant describes the expansion speed of space in the universe. If space expands too quickly, then the universe will spread out so quickly that material objects can't form. So you can't get stars and galaxies and planets and the types of things that we, of course, take for granted in our universe.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1/trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million trillion 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 trillion. I mean, that's like 1 atom in the entire known universe.
This fine-tuning is also evident at the atomic level. The strong nuclear force binds atoms together. If the strength of this force were to decrease by 1 part in 10,000 billion, the only element left in the universe would be hydrogen. Again, chemical life would not be possible.
Well, this is not unknown. In fact, these phenomena are fairly well recognized in the scientific community. In 1981, Fred Hoyle, who's dead now, he died in 2001, I think, he famously said, he was well known for his turns of phrase, he said, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The number one calculates from the facts seems to me so overwhelming as to put this conclusion almost beyond question. He was speaking about the properties of the carbon atom when he was writing about this. But it applies to these other factors as well. So, it leads one to ask, since there are so many of these, Lee Strobel said 30, different constants that have to be exactly right, why? You know, how could that be? It looks like a designer must have been involved. At least that's the argument. Okay, the second aspect of this fine-tuning has to do with our Earth. The way our Earth is constructed, where it is, and so forth. This is the Goldilocks principle. You know, not too hot, not too cold, just right. And it turns out that our Earth is just right in many very important ways. So here are some that I've listed. Okay? The right kind of galaxy that we're in. You know, a spiral galaxy and just in the right range, the right place. The location, the kind of sun that we have, and the distance from the sun. I mean, that's kind of obvious. But also the type of orbit that we have, a nearly circular orbit. The the tilt of the Earth on its axis, the presence of liquid water, the enough iron in its core to generate the right kind of magnetic field that protects us from the sun's radiation. All this kind of stuff. There's many, many of these things having to do with the planet Earth that seem remarkable and coincidental for us.
Strobel's journey through a universe finely tuned for life inevitably led him home to the blue jewel of our solar system, the planet Earth. There he encountered another array of critically balanced conditions essential to human existence.
When I was an atheist, I saw planet Earth as being one of probably billions of planets just like it all over the universe. I saw our sun as being an average, undistinguished type of a sun. I figured as I looked up at the stars at night that there must be millions and millions of advanced civilizations out there. I just thought there was an ordinariness to our situation. This line of reasoning was totally consistent with my atheistic worldview. But what I learned later is it is not consistent with what science is revealing about the Earth.
Strobel's investigation caused him to consider the many conditions necessary for a life-sustaining planet. In the process, he was introduced to the science of astrobiology and astronomer Guillermo Gonzalez.
I'm an astrobiologist, and what motivates me is just to examine the conditions necessary for life and look elsewhere in the universe and see if those conditions are met anywhere else. And the answer could be yes, and the answer could be no, and either answer is interesting.
For more than a decade, Guillermo Gonzalez has researched the characteristics of a planet required to support complex life. Estimates vary, but a current list of these factors would number at least 20 and include an oxygen-rich atmosphere, liquid water and large continental land masses, a home star of the right temperature and mass, an orbital path that is neither too far nor too close to the home star, A moon large enough to stabilize the tilt of the planet's axis and the movement of its tides. A magnetic field strong enough to deflect the sun's radiation. And a position in the relatively narrow habitable region of a spiral galaxy.
All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
Theorists have attempted to calculate the odds of all the necessary factors for life appearing at the same time on the same planet. A conservative estimate is 1 chance in 10 to the negative 15th, or 1/1000th of 1 1/trillionth. On those terms, even when compared to the billions of suns and possible planets in our Milky Way galaxy, the probability of even a single habitable world appears unlikely.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
Yeah, that phrase that Guillermo Gonzalez ended with, that the Earth is rare, is actually the title of a book that was published in the year 2000 by 2 secular scientists from the University of Washington. I don't believe they're theists, but they coined the term and recognized many of the same things that Guillermo Gonzalez was